Hello and Salam Sejahtera. My name is Armeylee Joneer and I am a postgraduate student from Universiti Malaysia Sabah, Faculty of Sustainable Agriculture. First of all, thank you for giving me a chance to present my research in this wonderful conference. The title of my research is Oil Palm Boiler Ash Effect on Acidic Soil Properties. So without further ado, let's see the introductions. So the soil that I use in this study is a type of soil known as acid sulfate soil. It is characterized by its extremely acidic nature, which is not suitable for crop cultivations. For example, like rice. Rice required soil with a pH of between 5.5 to 6.5 to grow healthily and produce high yield. So farmer will usually use commercial liming materials such as calcium carbonate and dolomite lime to improve the soil pH. However, studies have found that boiler ash derived from oil palm waste can be applied or utilized to improve the soil pH, while also adds nutrients to the soil. So since the oil palm industry in Malaysia generates huge amounts of biomass waste and leads to waste management problem. Utilizing or reusing oil palm waste can become a feasible approach to mitigate disposal problem and dealing with soil acidity problems and potentially replace conventional liming materials. Moreover, boiler ash has a very alkaline nature. The pH of boiler ash is between 9.2 and 9.8 pH value, so this is why boiler ash can be used to elevate soil pH. And aside from that, boiler ash has low degree of aluminum and iron toxicity, and it also contains large amount of potassium, which is an essential element for plant growth. So therefore, the residue from oil palm industry or plantations offer an attractive economic returns through the production of value-added product that can provide universal benefits, which indirectly overcoming problems such as environmental pollution, which is caused by a poor waste disposal management. And it also can become a key resource that can sustain the country's economy. This is also in line with the Sustainability Development Goal, which is SDG 1, SDG 2, and also SDG 11. SDG 1, the goal of SDG 1 is no poverty by making living from recycling materials from waste. The goal of SDG 2 is zero hunger or to end hunger and achieve food security by reducing food waste and also more use of organic waste. And the goal of SDG 11 is waste to wealth by investing in solid waste recycling technology to maximize the economic returns. The objective of this study is to determine the best soil boiler ash compositions for improving the soil pH of an acidic soil. Next, let's see the methodology. For the sample collection, the soil samples were taken and collected from Kota Belud, Sabah, and for the boiler ash, a local company known as Mahasawit produced and provided the boiler ash. For the soil sample preparation, the soils were ground by using mortar and pestle and passed through a 2 mm sieve. The soil and boiler ash were mixed together according to the composition. For the soil incubation, the soil boiler ash sample were incubated in a laboratory at a room temperature. There are a total of 12 treatments, and data was taken at every 10 days, which is at 0, 10, 20, 30, 40, 50, and 60 days. The parameters observed in this study are soil color, soil bulk density, and soil pH. At the end of this study, the best boiler ash treatment was determined. So these are the treatments and its boiler ash compositions. Treatment 1 or T1 is the control, which is only soil without the boiler ash addition. So the parameter can be divided into physical and chemical properties. In the physical properties, the soil color will be measured based on the Mansell color chart, and the soil bulk density will be measured by using the graduate cylinder method. And in the chemical properties, the soil pH will be measured by the H2O method. And now we move on to the result and discussion. The following graph shows the mean soil pH trend in 60 days of incubation. The highest mean pH was observed in treatment 12, which is 6.29, followed by treatment 11, 6.18. The lowest mean soil pH was observed in treatment 1, which is the control, with a pH value of 3.76. The mean soil pH in treatment 12 started to increase from day 40 to day 50 and then decrease in day 60. The soil pH of treatment without boiler ash remains relatively stable throughout the incubation period, which is at the beginning the initial pH was 3.68 and the final pH was 3.76, which is still falls under the acidic range. The result suggests that soil pH increased in response of the addition of boiler ash. It happens because of the alkaline nature of the boiler ash. Soil pH increased because of the release of excess residue alkalinity caused by the basic cation. So based on the result, all of the treatment shows an increase in mean soil pH. The highest increment in soil pH was 0.45 units in treatment with 20 and 40 ton per hectare boiler ash. However, the treatment with 50 ton per hectare boiler ash shows the highest final pH, which is 6.29 values with an increment of 0.38 units. Most of the treatments reach its peak at day 50 and start to decline afterwards. This can be due to nitrification. So in terms of soil bulk density, the soil samples have a relatively low mean bulk density. Soil with low bulk density cannot provide a strong support to bear the plant's weight, and it is prone to compaction and deformation as opposed to soils with higher bulk density. The highest mean bulk density was 0.92 g per cm cube observed in treatment with 6 ton per hectare and 15 ton per hectare boiler ash, and the lowest was 0.90 g per cm cube in treatment with 20 and 30 ton per hectare boiler ash. So in terms of soil color, the color of the soil remained unchanged, which is dark olive brown. Dark and brownish color of soil indicate the presence of organic matter. So generally, the soil that are darker in color and lower value on the Mansell color chart signify organic matter enrichment. In conclusion, the characteristic of boiler ash derived from oil palm waste on the use in soil amendments and liming materials were assessed and found to be highly alkaline and low bulk density. The addition of oil palm boiler ash increased the soil pH overall, and the addition of boiler ash at 50 ton per hectare, 20 ton per hectare, 30 ton per hectare, 40 ton per hectare, and 50 ton per hectare increased the soil pH to over 5.5. So therefore, it can be concluded that boiler ash derived from oil palm waste potentially can be used to elevate the pH of acid sulfate soil. These are some of the references I use in this study. So this is the end of my presentation, and I would like to thank you for your time and for your attention, and thank you so much for listening. I wish everyone all the best in the future. Thank you so much.